Scorpio, congrats on the first. Tomorrow, yes. I'll be streaming to tomorrow. Hello. How many firsts are you up to now? Let's find out. 8? All right. Dang, there's been a lot of firsts that have been like Anders hasn't gotten a first. Anders is number 5 there, and he hasn't gotten a first in a while. Hey, Bombax, it was fun to play with you for a bit. Konbanwa to you too. No, I yesterday I was streaming Hollow Knight, and yeah, I know. I wish I could play for longer, but um, I wanted to make sure that I get my math stream in. Um, oh, really? No, yeah, I was just like memeing about people like giving me money, and then Danny Highway actually like gifted subs, so you happen to get one. Oh, for in your time, it was probably past midnight. Yeah, it was in the afternoon for me, like late afternoon. So yeah, it was probably for you like today. Colded? Yeah, sorry, I took Tuesday off because I had to do some like real life stuff. I'm here now though. Just short circuit in Twitch database only dispatches data to get wiped out by the cosmic panic. It's ruining the world. Oh my gosh, yeah, he's got more than double of you, Eldritch. That's funny, yeah, I didn't realize that's how the timestamps would work, but I guess that is what that makes sense. As for you, it's about to be tomorrow though. After like another hour or so or whatever. So yeah, cool. If you have a question, let me know. If not, I'm gonna pull something up to study from. Um, this is a Papadori. I guess I'll keep that one up in case Papadori wants to talk about it more, but I don't know what to do about that one. This one I think we can safely delete. Oh my god, I forgot about this question. Oh yeah, that was Pullman's last question, and we can delete this. I think we're done with that one. Really? I should just be deleting the page. My poker face. You can delete that page. You can delete that page. Oh yeah, this question. We can delete that one. That's an interesting one. Oh yeah, this was critical differential equation. That geometry one I'm done with. That analysis one I was doing before, I don't know that I actually finished it up. I guess we'll keep that one there. God, this is so much. I have not been cleaning up this file. This file is supposed to be for the physics mechanics studying. No worries, Bombex. Thanks for popping in. Okay. Um, Okay. You know, let's even... no. Okay, we'll just go into a fresh page. Okay, so I'm going to pull, I think, an analysis question to start with. This is what we're doing on Tuesday night. We got through number 3. So let's look at number 4. That looks like a good one to try. I'm kind of into this song. Let's like it so I can find it later. Actually, the Taylor series impromptu were for all of these. I do want to get the Taylor series for part D. We skipped over that one, but I feel like I need to see it. Hey, Green FR, I'm doing good. How about you? Have you been here before? I feel like I kind of recognize that name, but maybe not. Okay, so those are 3 of the Taylor series impromptu. The other one is the Taylor series for 1 over 1 plus x. And so I think I was having trouble figuring out live on the class, but I think it's minus x to the n. Because it's like the formula for the sum of a geometric series, a over 1 minus r, but a is 1 and r is negative x. So you know, I kind of like writing it with the negative 1 split out. Do you have math burnout famished? I'm sorry. It does sound like you've been going pretty hard in the math for a while now. That's definitely like understandable. I'll probably feel the same. This is a problem from Colded. Do courses 155 courses intermediate algebra. Yeah, it's true. A line L0 defined as 2x plus 5y equals 11 rotates anti-clockwise about a point alpha beta. Oh no. Wait, okay, alpha beta is a tuple of integers that lies on the line that minimizes the absolute value of x plus y. That's a hell of a definition. The answer is B, C, D. Okay, thank you for telling me. Pressing keyboarding. Want to be able to type with light speed? Oh, nice. Turn angle -1 to the n end times n degrees in the nth second? What? If line L0 becomes line Ln after n seconds. That's a crazy... Okay. Dn denotes the perpendicular to the origin from Ln. What is this question? Oh my god. There's a valuable skill in any field in tech. Yeah. I mean, I'd say particularly so if you have to like, if you're in some kind of role where you're like taking notes or something like that. Like, I mean, there's a lot more like jobs in this, I'm sure, but like, I think of like the people in like courtrooms that like type everything that's being said. Okay, well, first off, I guess like, do we want to solve? It feels like we have the first problem is to figure out what alpha and beta are, and once we know that, we can start to think about d sub n. And I hope those are entirely separate problems, and like we can just think about the alpha and beta. Um, Separately. So I think we can argue the set is probably it should be a singleton. Um Hey Kusaima. And this looks like if x and y are restricted to integers, like surely we can solve this equation somehow. Like maybe we could solve it for y and numbers might be small enough that we can guess and check. Or maybe well, okay, what does y equal here? It's 11 over 5 minus 2 over 5x. Phobos, hello, hello. It's good to see you back at the Code Rose. Chemistry? I don't really know chemistry. Sometimes people around in chat who know chem. Um, my memory of chemistry is really it's really faded though, since I took the class. Roasting felt good, yeah. You make an excellent roaster of code. Um, okay, so my initial idea was to try plugging in integer values of x and seeing what integer values of y we get. But could we also think about the absolute value of x plus y and how, based on what I just wrote, that's the same thing as x plus 11 over 5 minus 2 over 5x, and figure out what value of x minimizes this? I don't know if this will actually help, but let's Let's just go down this path for a little bit. I forgot my x. So if we're restricted to integers, x is going to need to be negative. And a -4 looks like a good candidate. We need to make sure it gives us an integer y. It's okay if this quantity isn't an integer though. Why can't I do math? It'll be a fifth. So if x equals -4 over here, we get 11 over 5 plus 8 over 5. That's not an integer for y, unfortunately. Let's be a bit more organized about how we're doing this. So let's try like a -3 is the next integer for x that minimizes this, right? No, or is it negative? No, it's -5 is the next closest, right? Because 15 is 4 away from 11. 9 is 4 away from 11. So, okay, -3, -5 are equally acceptable. Possibly only one of those gives us an integer for y, though. I don't know, but I hate chemistry and tomorrow's my paper. Oh, no. What is paper on? Oh, you mean, or maybe you mean like a test? Like, yeah, I mean, I'm not a fan of chemistry personally either. Tests? Okay. Good luck, but yeah, I'm sorry, I just don't know it very well. Cool, dude. I had a thought, if we multiply and divide by √2 on absolute value of x plus y, and you want to think particularly about x plus y over √2. Oops. The distance on the point xy from the line x plus y equals 0. So we need to minimize that guess. I assume this is a formula that I don't know then. It does kind of remind me of the formula for the distance between a point in a plane though. So I can buy this. Okay, yeah. Okay, so I guessed right. um Interesting. Isn't the point 1 comma 1 though? No. Yes. Wait, okay, so formula ax plus by plus c or root a squared plus b squared. Never mind. Wait, where's the point come in this formula? No, the point is a and b, right? For a given x and y. Isn't the distance xy is the point? Okay. So isn't the point in this formula 1 comma 1? Ace the 13th, maybe? Thank you for the follow. Those are the coefficients. Oh, you're right. Thank you. Yeah, my bad. Yeah. Sorry about that. Right. So then this formula is distance from any point x comma y to the line x plus y equals 0. Okay. Thank you for walking me through that. And you're saying we need to minimize that guess. I mean, the minimum, though, is x equals 0, y equals 0, isn't it? Like, we have to bring in the other constraint at some point, I guess. Or, like, yeah, we have to involve the line. Um... So, I mean, the natural way to me to involve that constraint is to plug something in for y, or x, I guess. But aren't we just doing the same exact thing that I'm doing here, but more complicated? Unless the geometry of this helps us in a way that I'm not seeing. But I still feel like we're guessing and checking. Maybe drawing both lines would help. I guess they should intersect somewhere, right? It's just that might not be at integer values. It's the part of everything being integers I think is making this complicated. The other line is something like that, I think. This is a better task for Desmos, I think. But let's not draw this by hand. I think we want to be more exact. Then I can easily draw by hand here. But it's an interesting thought, Colded. I'm just not entirely convinced, or I'm just not quite sure how this is gonna be helpful. It could be though. Like, I'm just not seeing it yet. So they intersect, okay, yeah, at non-integer values. Um, oh, thank you, Brian. You don't have to apologize. It's better than 0 bits. Thank you. People, yeah, 1 million bits. Uh, Maybe I still have a hard time interpreting what we do with this graph, to be honest. And hey, Mariel cutting. I'm working on a different problem right now that might take me some time. Let me try and quickly answer your question, which is there's something called the rotation matrix that I think is what you want. So this matrix here will give you a counterclockwise rotation by an angle theta. So I think the answer to your question is take this matrix here and plug in theta equals 45 degrees. And I'll link you this page. Thank you for the question. Um, the Desmos does do something, or like we can, like this is an integer x, right? No, it's not. So -5 wasn't gonna work. -3 wasn't gonna work. Ooh, there's an integer x though. X and y. I just got it numerically, Fembox. Proof by Desmos. Wait, no, that's a half. I wish I could make these tick marks go by ones. Did you do guess and check? Because that's basically like that. I feel like that's just the best strategy here, to be honest. It's a small enough problem that I personally would just guess and check this. Um, so yeah, and cool. I don't know. Like this is a neat idea. I just don't see how you use it. There's probably some use of it somewhere, but I don't know. Can I get the integer points on the line L0 5 apart xy's and 2 apart yy's. Ooh. Because 2 and 5 are relatively prime. Yeah, I was trying to think of this, like, it sure looks like a linear combination. Um, the issue is that I guess we're not equal to the GCD or LCM or whatever you write. I think the GCD. So maybe that's not the right train of thought. Oh, you know what? It's a really you could guess too really quickly by looking at this form, I think. Like we need to make these fractions go away to give us an integer for y. Um and so we could add 4 to 11 to make 15. And the quickest way to get 15 here is to take x equals to negative 2. That's actually, I think it's my favorite way of thinking about this. It's still guessing and checking, but it's more educated guessing and checking. And x plus y equals 1. We're not doing better than 1 when x and y are integers, because we know they can't both be 0, I think. Well, yeah. Or we know x can't equal y. So I think that's actually enough right here. Like, I think that's how I would recommend thinking about this. It'd be nice to have a fancy way you can just find it, but I don't think there's anything wrong with this logic here. Um, yeah, to be honest, I should have tried this. I should have tried more directly looking at the fractions earlier. Now the rotation stuff is tricky. So we're rotating about this point here, -2, comma 3. Yeah, exactly, Fembox. The alternating degrees is super strange. Um, but it is kind of like partially erasing itself, as you say, where um instead of, let's call this L0. So in L1, we're rotating -1 degrees anti-clockwise. So 1 degree clockwise. So I think L1, if I exaggerate the difference, is like that. But then L2 is going to go 2 degrees the other way. Which basically means it's going to be 1 degree past L0. Like, these are going to be reflections of each other, I think. Wait. Wait. Are we rotating from L0? Or are we rotating from L1? I assume we're rotating from L1. You think so too, Fembox? Okay. Uh, yes, Jed. But I was just wondering if we're rotating from the last place we left off, or if we're always rotating back from L0. Like, if it's recursive or not, I guess. I think we're doing it like, for L to make L2, you start with L1 and rotate 2 degrees. It's just a feeling, Colden, for why with L1. By the phrasing of the question, I don't have a very good justification for it. I feel like it's not clear. Did I mix up? No, wait. I think I got L1 right. This is like clockwise is this way, and we went negative anti-clockwise. So yeah, I think I would argue the question is a little bit vague on that rotation aspect. But I think this is the right interpretation. Oh, relative to L0. Yes, Jed. Yeah, Colton. Um, dn is the perpendicular distance of the origin from Ln. Oh, wait. We should talk about A and B first. So, spoiler alert, the answer apparently is BCD. But we know what alpha and beta are, so we should think about options A and B, right? Um, -14 plus 15 is indeed 1. -10 plus 6 is 4? That's not good. Wait, Colton said it was BCD, right? Oh, you retracted it. Um, Oh, it's -4. Thank you, Golden. Yeah. Okay, I messed it up. Okay. So yeah, I agree then that at least from the first two options, B yes, A no. Um D90 is rotated 45 degrees. D180 is rotated 90 degrees. Uh it's only you only cut it in half. Oh wait. You only cut the even ones in half, right? The odd ones. No, it's also cut in half. It's something like that, Fenlox, but I think there's some weirdness happening with like 0.5s that we need to take care of, but it's something like that. Dang. Okay, Spotify's doing a good job with this playlist. I like this song too. Um, perpendicular distance of the origin. Well, the first question is whether we actually pass through the origin. Uh, wait. Oh, wait, never mind. I thought we were trying to minimize the distance, but that was from a previous part of the question. I see what you're saying now, Penbox, where we should think about D180 and D90. Um, let's think about that harder then. So -2 3 is educated guess and check, Jed. Uh, verified with Desmos, but if you solve this equation for x and for y, you can just kind of look at the fractions here and figure out that x equals -2 is a really good guess. And when x and y are integers, you're not going to do better than x plus y equals 1 for the absolute value. Vivian, can I do calculus? Yes. Feel free to put your question there in chat, or if the screenshot is easier, you can put it in my Discord. And we're going to this question first, but you can be right after. So when n equals 1, we rotate -1 degrees. When n equals 2, we rotate +1 degrees. Hey, Marin, it's going well. How about you? So when n equals 3, that's when we go to 2. -2, I guess. 4 is +2. Is it? Wait. Yeah, it has to be. So I think we're cutting it in half and doing the ceiling. Six. Yeah. Okay. So oh, awesome, Marin. Hey, underscore. Ceiling. Oop. N/2. I guess 180 and 90 are both even numbers, so I didn't have to worry about that, but it was bothering me. So do we want to think about D180 first or D90? I think I'd rather do D90 because it's... How do you rotate a line, I guess? That feels like... linear algebra can help you there. But we're not going through the origin, so that linear algebra is only so helpful. Unless we can think about a different coordinate system where the line does go through the origin, do the rotation, and then translate it back. Yeah, okay, so I think this equation, we have to chop off the y-intercept. But like the vector that represents that equation, I guess would be um 1 and minus 2 over 5? Does that make sense? How would that vector look? It's coming from the origin now, and that's okay. If x goes positive 1, y goes minus 2 over 5. That seems okay to me. I drew that arrow very tiny. So what I want to do is take this vector, rotate it by 45 degrees, and then do the reverse of this process to get back to... Do we want the same? No, it's not the same y-intercept. We need to take the origin as the point we're rotating around. That makes more sense. And it's still the same direction. Sounds good, Vivan. This problem's going to take me a little while. I will get to your question though. If you need to like get up and go do something for a little bit, it's okay. I'll type your name in chat when I switch to your question in case it helps. Okay, so we're going to pretend that this is the origin, -2, 3. In worst case scenario, I'll get back to you in Discord too, but it shouldn't take me that long. We can still use the same formula here. We just need to make sure that we're thinking about it in the right way. Or the same like representation here. So if we want if n equals 90, then we have it's a positive 45 degree rotation, anti-clockwise. So I was literally just looking at the rotation matrix as someone asked about it. It's kind of funny. I feel like people ask about things like things in themes, where like different people have the same like type of question. You think D is correct, you doubt C is correct. All right. So cosine of 45 degrees is root 2 over 2. They're all root 2 over 2, but we just follow the signs here. The SIGNs, not the SINs. And we're multiplying 1 and minus 2 over 5 into this matrix. So let's go get some math done. Root 2, I'm gonna write this out. There's no way I'm keeping track of this in my head. Plus 2 root 2 over 10, right? My mind isn't playing tricks on me. Wait, 2 by 2, 2 by 1. Okay, yeah, right. Um, 2 root 2 over 2 minus 2 root 2 over 10. Wait. No, 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 no. There's no 2 there. Hey, Athan, if you have a question for you to let me know. This is a more advanced problem, but um, if you have a question, I would happily do it too. Since we were rotating about another point, we went to yes. So I'm, for the sake of this math here, I've implicitly shifted the origin to minus 2, 3. I probably should make that explicit, but we're gonna have to do some shifting back, which is which we can do because this is just giving us the slope of the line, and we know what point it should pass through, which is negative 2, 3. So we can always get a new equation for the line. I don't know why I'm pointing so much, by the way, but you can't stop me. This is what, 7 root 2 over 10? And this is 3 root 2 over 10? Because that's our new slope. Well, how do we think about that? Rise over run? M equals 3 root 2 over 10 over 7 root 2 over 10. We're going to verify this in Desmos, by the way. But allegedly, our new slope is just 3 over 7. Our original slope was minus 2 over 5. Our slope changes from negative to positive. Is that reasonable? Let's just see how it looks. We know we're passing through the point negative 2 comma 3. So let's use point slope form. Uh, 6 over 7 plus 3. 6 over 7 plus 3. 21 plus 6 is 27. Okay, let's see how that looks in Desmos. Three over 7x plus 27 over 7. That is not a 45-degree rotation. Anti-clockwise. That might be 45-degree rotation clockwise. Oh, that is anti-clockwise. I was picturing the wrong thing entirely. Oh my god. I thought we were rotating the other way. Okay. Oops. I was expecting the wrong thing. Chemistry, I'm sorry. I don't really know chemistry. Ramachandra. It's been so long since I've taken a chemistry class. Yeah, okay, so that looks about right then. And so then the distance from the line to the origin, we can use the formula that you put earlier, I guess. Which is ax plus by plus c over root a squared plus b squared. And I assume for this formula to be true, we should write the equation 3x minus 7y plus 27 over 7 equals 0. Physics? Kind of. My physics is pretty weak too. It's better than my chemistry. It depends on the question, to be honest. I feel like I can try putting the question out there in chat or in my Discord. And Mateo, say there's a square divided into 9 equal squares distributed across 3 rows and 3 columns. We want to choose 4 of the 9 squares that they distribute across all 3 rows. In how many ways can such a choice be made? That's an interesting question, Mateo. It's going to take me too long to figure that out on the spot here. I'm going to make a queue, guys. It's getting to be enough questions where I think I need one. We're currently working on Colded's question. Next is Vivon09. And then we'll put Mateo in after this. And then Ramachandra, if you do post your question, I'll add you in here. Yeah, sorry, when there's multiple questions that are being asked at the same time, there's only so much I can do. So I'm sorry about the wait. Okay, so we want to find the distance from this line to the origin using this formula, because why not? C is 27 over 7. Root a squared plus b squared. 9 plus 49. 58. What's the prime factorization here? 29. Disgusting. (27 root 58 over 7). Ew. This is D90, I think. We have to square that number? There's no way this is 16, right? Did I do something wrong? Oh, no, 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 no. It's just 27 first off. You're also right about that, Colded. I don't know how it went up. Okay. Now this is potentially... We still have to do 27 squared? Why? Do they share a common... No, they don't. All right. 29 times D90 squared. At least the root 58 gets a cancellation. The 27 squared, we just have to do some good old-fashioned calc... Well, wait, no, we might not. 27 squared over 2. That's not 16. I can tell you that much right now. Yeah, D90 has to be less than 1. And this number is not less than 1. Um, did I mess something up? When n equals 90, it's a positive rotation, which is anti-clockwise. Eldritch Hay again. I mean, theoretically possible has 183 protons. Okay. That sounds fancy. Better stop thinking at 3 a.m. The best time to think. The CIA will haunt you. um, I don't see the issue with the math that I did, but I don't know why it's not giving us the right answer. And Benmox is getting a completely different answer for D180. Oh, wait, no, we haven't found D180 for ourselves. Um, do we lurk and sleep? All right, it sounds good. I don't know what to think about this D90 thing. Um, the more I think about like D180, this is the original question, Vivon. It's from Colded. Um, it's a pretty weird question. D180 is just a 90-degree rotation, and that has a known formula, right? You just flip the slope and negate it. Do you have the same y-intercept? No, you probably can't. So I guess let's look at D180. Because you don't have to do linear algebra for that, at least. The D90 thing, I don't know what to think of that. Wait, doesn't D180 have to equal D90 for these equations to be true? Or negative, maybe? But what's a distance? Something fishy is happening. Let's think about D180. Um, we get the equation y minus 3 equals... Now the slope is positive 5 over 2. Times x plus 2. Plus 8? That looks pretty perpendicular to me. Yeah, that's kind of funny, Colded. I don't know if we can use that fact in any way, but it might help us figure out what's wrong with D90 if we can do this D180 correct, I guess. Um, so D180 is 5x minus 2y plus 16. Jathan, it's related to linear algebra for sure. We're using some linear algebra in this question. $25 plus 4 is 29. Here's the 29 showing up in our lives again. So then 29 times 16 over root 29, oops, squared. Hey, that's 16 squared. Why? So we expect 4 over root 29 for our answer. Or for D180 and D90. I'm not getting that though. Huh. Oops. Am I doing the formula right? Yeah, that looks okay. Yeah, B is definitely correct. Apparently C and D are also correct. Colded said that all three of these are the answer. And we've been trying to justify that or explain it. Um, but my numbers just aren't matching, and I'm not sure why. Yeah, that page of Wikipedia last night. Yeah. That's Galaxy Brain Central. And if my equations for the lines are right, then like what is there a mistake in the answer key? Like well, I'm getting only B Colded. Yeah, I'm getting 16 squared for D. For like I would put a squared on answer C. So yeah, 16 squared. You're getting to the same too? Alright. And then for the one with D90, I'm getting 27 squared over 2, which seems pretty off. So I don't know. We might have to hang it up there because I'm not sure what I'm doing wrong if I am doing anything wrong. Yeah, I'm sorry. I'm gonna start pulling up Vivon's question. Vivon, if you're here, still let me know. You are awesome. Okay. It's a little bit small, but let me if B and T are real numbers. You know, let me just retype this. I doubt it's gonna be readable on stream, and I don't want to like blow it up enough that it'll be readable. Oh wait, I have a simpler idea. Oh, dude, I'm a genius. Well, 1 second. Because I just realized it's gonna be annoying to retype all the or to get all the options in here. I just took a screenshot of the image you posted. Yeah, no worries. I know getting a screenshot. It's sometimes weirder if it's not going to behave. Okay, that should be more readable. Interesting. Geometric, alternating geometric, which we can deal with. Okay, these are all geometric, thank God. Okay, looking at option A, this fact is very important. So for a geometric series, the normal way that geometric series are written is that they're of the form from n equals 0 to infinity of a times r to the n. Let's call it as b. And the sum is a over 1 minus r, but the absolute value of r has to be less than 1. And using k instead of n, but that's okay. T is smaller than b, the absolute value. So all of these fractions are less than 1. So that's perfect. All these geometric series will converge, and we're allowed to use this formula. The first one, our a, it's on the outside of the summation, but that's fine. It's still a, is 1 over b squared. And it's being divided by 1 minus t squared over b squared. And so let's just simplify this and see what happens. The b squared goes to the bottom and gets multiplied through. So 1 over b squared minus t squared So nearly right, we just don't have the plus sign there. We have the minus sign. So that's not going to work out. So A, no go. B, I want to rewrite it. Because the -1 messes with like this form of a geometric series. 1 over b squared. The thing to notice though is that these two numbers have the same exponent. They're both to the power of k. And when you do that, you can group them underneath the same set of parentheses. So it's -1 times t squared over b squared to the power of k. And then -1 times a number is just the negative of that number. So I'm just going to put a negative there. Now we can do the exact same formula. So 1 over b squared over 1 minus negative is just plus. Now let's simplify this. 1 over b squared plus t squared. All right, perfect. So yeah, b is what you want. I assume there's only one answer that's possible. We could also check C and D. It'd be basically the same process though. And I think neither of them should work. I'm gonna do it like quickly in my head here, but yeah. Think it's good? Sophomore in AP Calc. Oh, nice. Wait, you're a sophomore in AP Calc BC? Holy crap! I did that my senior year. Well, you're getting a great head start then. Keep it up. Yeah. Oh, and you know what? I need to be better about advertising this. Feel free to always click on me with questions too, but there's another person who does math help on YouTube. Actual Education, aka Dr. Gold. So if you're interested in, if I'm not around, feel free to like, or or just in general, if you like him more. That's another like resource for you. All right, let's work on Mateo's question. Mateo, sorry for making you wait. I'll type your name in chat too in case it helps get your attention. And we can delete the queue now. Okay. So my mind immediately goes, like, just with 3 choices, we can already cover all 3 rows and all 3 columns if we take these 3 squares. So this is, and so then we have 1, 2, 3, 4, 5, 6 choices for the other, for like the 4th square. So that's just, from this arrangement, we get 6 total choices. But I think we can name some other arrangements too. So let's think about other possibilities. Like, can we do this? This should work. And we have to think about every way that we can rotate and flip this, right? So we could rotate it, give it, like, I guess a quarter of a turn that way, get something unique. Give it another quarter of a turn that way, get another unique thing. And then even another quarter turn. This is feeling like a dihedral group right now. So I think we have 4 rotations. But we could also reflect it. Or is a reflection the same thing as a rotation here? We got to think about that. Let's draw it out because I can't visualize it. If we just do a horizontal reflection, this is what I was imagining would be a quarter turn, right? Is there a different reflection that would... get us something unique? If I reflected it across that diagonal there... No, that's 2 quarter rotations, right? A vertical flip surely wouldn't be any different, right? That'd be 3 rotations. Yeah. Okay. So I think 4. Is all we get from that. Finvox, so I don't know exactly when, I guess you haven't talked in a minute. So I did this series problem, which you probably missed. But the problem you probably asked about is the rotating line one. The answer is no. For the part with D180, I get 16 squared, not 16. And for D90, I get 27 squared over 2, and that's kind of strange, but I can't find a mistake in my calculations, and Colda didn't get anything different either. So I just kind of, there might be a mistake in the answer key, or I don't know, because it's kind of inconclusive about C and D. Like I feel like there could be a mistake in the prompt or something. So I guess I didn't get a satisfying conclusion to the problem now, but based off like D180 and D90 should be the same number based off how they're, because these are the same equations. That's what you got too? Okay. Can we tell visually if, just by Desmos if they're not the same number? That's a little bit hard to judge. They look pretty similar. Like they look like it could be a similar distance. Like on the green line, somewhere around there is probably closest. And on the purple line, like somewhere around there is probably closest. So it's hard to eyeball it and see if they're really different. But yeah. So it does say the answer is just B, but I feel like it's more likely there's a mistake in the question or something. And like they probably meant for like C or D to be right also. Yeah, I've been working on this one. Um, and so I was about to ask, what happens if we just took this square and moved it to the right by one? Oh, parkour. But if we did do that, we're back into these cases over here. So that's not anything unique. We could take it and move it up, though. The green line is further from the origin than the purple one? Really? Or like, that matches with what we got, right? Yeah, I think the blue's my favorite famished. It's a nice color. I tried to make it match the blue that's in my channel logo. It's kind of hard to get the LEDs to be accurate though. They don't really represent colors very accurately from what you put in. The green one represents D90. Is 27 squared over 2 more than 16 squared? Hell if I know. I ordered them off Amazon. They're Govee, I think they're called strip LEDs or something like that. Oh, yeah. If refreshing or pausing and unpausing doesn't help, then oh, you know what? There is a setting. It took me a long time to figure this out, but in the video settings, there's a low latency mode. That makes the quality a little bit worse, but your stream is way more current. I want to pull up and show it because it was like it's on mobile as well. But I was wondering why everyone else was always ahead of me. And eventually I figured out that that's why. Oh, I'm showing it right now. I didn't realize I was showing my thing already. You go to the settings icon there, advanced, and then the low latency one. So if anyone finds themselves like consistently like behind the others in chat, that's probably why. Your network's pretty damn fast for Twitch. Oh, interesting. Well, Fenbox is he manages a tutoring center if I remember right. So you know, it is his job to do math at work. Yeah. Ugh. At a community college, that's right. The green line is further from the origin of the purple one. I'm just gonna take your word for it. They look almost like the same. Oh, you can kind of tell based off the intercepts. Yeah. This one's at 3.2. That one's at 3.8. Yeah. Yeah, it doesn't seem like they should be equal then. Yeah, it's not a bad idea, famished. I think we can get we have another set of things here. If we take this, then we have 6 other choices. But we could also rotate these and we do get unique things, right? So we're going to do 6 and we're going to multiply it, I think, by 4 for 4 rotations. We just need to make sure we're not double counting anything. And we would be, because the middle one would get counted 4 times, right? Oh, you're right, Benbox. You're right. Thank you. Yep. I forgot about that requirement for some reason. So we could take this one and shift it to the right by 1, or even 2. Um, uh, so we have all the rows. This one can go like here, down 1, or down 2, and we're still equally valid, right? And we have rotations to think about. I think it'll be simpler. Oops, I mean to. That's just one arrangement there. And then maybe separately. We think about the other cases where it's up in the corner. Because otherwise we're going to double count that if we start rotating things. So if we do that, I think we have 4 quarter turns that we can do, right? Because that's a unique thing, that's a unique thing, that's a unique thing. Okay, simply facts. And then like a vertical reflection would get us new arrangements. So that's 4 times 2. What is Gauss method? Gauss method for what? For simultaneous equations? Oh, like Gaussian elimination? Like, are you working with matrices? No? I wonder if that's just another word for elimination. Okay, I think I know what you're talking about. Guessing elimination of Gauss got rid of his mathematical rival. See how megalomorph. We can take this equation as an example. Ignore the stuff below it, but we can solve this. With elimination. I want to. I want to finish with the question I was working on, but you can be right after that. I'm going to write this one down. 3x plus 4y equals... Let me just do it as an example. 7. 4x minus 2y equals 5. So actually, I guess one more question. Are you doing things like you're adding these two equations together like that? Because if that's yes, then I know exactly what you're asking about. You're going with 36? Mateo's saying the answer is 45. What am I up to? 11 plus 8. I'm up to 18. I need to make progress a bit faster here. Sorry, that's a horizontal. Wait. No, vertical reflection. No, that is a vertical reflection. A horizontal reflection accomplishes the same thing, though. I was imagining a line that goes horizontally causes a vertical reflection, I think. I was just getting mixed up with that, like, terminology. You don't know why. I don't know why either. I'm starting to run out of arrangements here. What else can we do? Oh. I mean, on this first one, we could have taken the other diagonal, right? And we don't run the risk of double counting anything. I don't think. No, we don't. So what does that bump me up to? 12, 16, 17, 25? That's progress. Six distinct ways to start in 6 empty holes for the 4th. Interesting. For some reason, that's undercounting. I wonder, does that not capture this case? Where the first 3 don't satisfy at all? Yeah, okay. It sounds like Lubert is pointing out the same issue. That does capture... Oh, I think it doesn't capture this case either. It does capture these 2 cases, and probably more than I'm missing. Oh wait, does it even capture this one? Wait. Apparently I'm missing. What other arrangements were just 3 of them? I'm confused what other ways there are to use 3 to satisfy all 3 rows and all 3 columns. Besides choosing the other diagonal, but I'm just getting 12 by that logic. Mateo is saying this arrangement. Do a front flip. Yeah, I haven't captured that, have I? Okay. You can definitely rotate that and reflect that. Well, just rotations would take care of all that, I think. So that counts as 4? So wait, so these on the right are the 9 that you missed? Megalomorph might be easy to do complementary counting. The number of ways to distribute 4 without any restrictions. Subtract out the number of ways to not use all 3 rows. Oh, I don't see how this one was counted in yours, Fembox. Oh, because of these 3. Aha. Or sorry, I'm not drawing it right. That makes sense. Yeah, yeah. Okay. So I'm still missing some case things. I'm not adding up to 36, but interesting. Megalomorph, subtract off the number of ways to not use all 3 rows and all 3 columns. I think you still have a lot of cases to worry about, though, maybe? I don't know. I feel like I'm kind of back to square one if I try to do... I don't know. I'm not too good at these types of problems. Yeah, I guess and I feel like we're still getting a bunch of like cases there. It might be overall easier. You're right. There might be like less cases. Too tired slash lazy to work it out. Fair. Um. So, Mateo, I guess the technique that at least we've kind of arrived to is do what Fembox said, which is considering all the arrangements where the first 3 choices satisfy the requirements, and then you have 6 choices for um the 4th square, which will get you to 36. But then you have to realize that, or you have to think about other scenarios over here on the right where the first 3 choices don't satisfy it. And I think that's the best logic that I can think of to solve this problem with. Unless you want to go down the path like Megalomorph is saying with getting the total number of arrangements and subtracting off the ones that don't work, which could be easier, but I haven't worked it out either. So I hope that at least kind of helps. I don't know if a good like I don't know if there even is a systematic way of like doing this, but besides kind of what we said there. I do want to solve simply facts system of equations here. I know are you still here? Simply facts. I'll still work it out regardless. Maybe they'll check the VOD later. Hummus, I'm just going to do this problem relatively quickly, and then if you have a problem, I can work on that. I feel like I have to sneeze, but it's not coming. There it goes. Okay. Yeah, feel free to put your question right there in chat or post it in my Discord if a screenshot is easier. And then I'll start working on it soon. Okay, so if you want to solve a system of equations, I'm presuming this is I learned it as elimination, but the Gauss method I think is going to be the same thing. The goal is to add or subtract these two equations together in a way that gets rid of one of these variables. And the way you do that is by choosing one equation and multiplying it through by something, or sometimes both. But I see if we were to take this bottom equation and multiply it through by 2, we'd have a 4y and a 4y, and that's perfect. So I'm going to take that entire equation, multiply it by 2, and we'll get 8x. I mean, I shouldn't do an equal sign there exactly. I'll do an arrow. No worries, Mateo. Thank you for the question. 8x minus 4y equals 10. And then the top equation, I'm just going to bring it over as it is. 3x plus 4y equals 7. And now that the y's match, they have opposite signs. The top one is plus 4y, the bottom was minus 4y. I'm going to add them. And now you do the x's plus the x's. So 3x plus 8x is 11x. 4y plus negative 4y is 0. And then 7 plus 10 is 17. So divide each side by 11 now, you get x is 17 over 11. Oh, well, this is just a program that I'm using right here. It's called Journal++. I did used to have a whiteboard, like a physical one that I would draw on. I just bought that off Craigslist, though. But the program I'm using that's on screen right now is completely free. Okay, so we know that x is 17 over 11. Now we can just plug it into either of these two equations and find out what y is. They look equally annoying to plug into. I'm just going to choose the top one for fun. So 3 times 17 over 11 plus 4y equals 7. Let's simplify this business. You multiply the 3 into the 17, which is 51? Plus 4y equals 7. Now you subtract the 51 over 11 to the other side. That's annoying. That's going to be 7 minus 51 over 11. I'm going to go off to the side here and do side work. Get a common denominator. So multiply it by 11 over 11. 7 times 11. Hey, it's 711. Is 77. Now they have a common denominator, you can subtract across the numerators. That's 26. So we get 4y equals, these are disgusting numbers. 26 over 11. Now divide each side through by 4. 26 over 11. Dividing by 4 is the same thing as multiplying by 1 over 4. I'm going to cancel 2, because 4 divided by 2 is 2, 26 divided by 2 is 13. So now you get 13 over 22. So the final answer is that x equals 17 over 11, y equals 13 over 22. So if that helps, simply facts. You're also, the other thing I'll just kind of like say in general is that if you subtract the two, like in this one, I added the two equations, but if you subtract them, you should be careful about the minus signs. It's an easy mistake to make. So if I just take these two equations and subtract them for fun, well, yeah, I'll just subtract them for fun. I won't mess with them. No, I will mess with them. I'm gonna magically change this 3 to a 4. Just to get a slightly different example where we prefer to subtract them. Because now the x's match, but they have the same sign. They're both pluses. Before we had a plus and a minus. But now that the signs match, we want to subtract. And we need to make sure that this minus sign goes to every single piece of the bottom equation, is the thing to remember. So it's 4x minus 4x is 0. But I'm not going to write the 0. It's 4y minus negative 2y is positive 6. And then it's 7 minus 5 is 2. So that's the only thing to like watch out for. Okay, so I think that wraps up this little system of equations problem. So Hummus, did you post your problem? I don't see it. Miss the easy days in math, Zavin? I don't. It does get a lot harder, but it also gets cooler in my opinion. Yeah, I completely agree, Zavin. Having that Journal Plus Plus, I don't mind it. It does seem to slow down the longer you have it open. Like I've noticed towards the end of streams, it gets a little bit laggier. Other than that, though, I quite like it, and I think it's open source too, or it's always like completely free. Um, I probably wouldn't if just using a mouse though. Like, I mean, nah, it's still better than just like paint, but um, yeah, I don't know. I like it. And eventually, I want to make a plugin for it that can like integrate it with Twitch in ways that might be fun. But that's a long time off. I there's other things that I want to build first, like a queue system that I haven't even started on. Um, oh, okay. Looks like we got a question posted. I assume this is from Hummus in the YouTube chat. You want to know about question 26? Let me boil a screenshot down to just 26, and then I'll bring it up on screen. Looks like a complex number question. And I'm pretty sure this is the program that Bobos uses as well, so that's another person who presumably likes it well enough. Ooh, Lubert tried Megalomorph's ways. Oh, nice. 6 choose 4 ways to leave a row or column empty. So it's 9 choose 4 minus 6 times 6 choose 4, since you have 6 choices for the empty row or column. Add back in any overcounts. No 2 rows can be left, both be left empty, but a row and column could. Oh, yeah. Wow, Lubert, nice. Mateo, I'm not sure if you're still here. I'm going to copy paste what Lubert is saying into the YouTube chat. In case you want to have like a copy of it to read separately. I'm gonna have to break them into multiple chats though, because YouTube has a stupidly small character limit. Yeah, that's definitely a lot shorter. Like that does look like a more like elegant way of doing it. I think. Okay, let's try this one out. If Z and W are two complex numbers simultaneously satisfying these two equations, ooh, we have to figure out. So we don't have to necessarily solve them, but we'd have to figure out if they're purely real, purely imaginary, or neither, I guess. I assume this means like A plus IB, where A and B are both not zero. If they're saying it, because they left off the word purely there, so I'm assuming that's just any imaginary number, which is also, yeah. Okay, so how do we think about this? Z cubed plus W to the fifth equals 0. And Z squared times W conjugate to the fourth equals 1. Well, it does seem like we want to... I see the title list as nth root of unity. It seems like maybe we want to substitute the Z or the W in this equation to get it in terms of one variable and solve that. What's easier? Also, I assume if you have W to the fifth conjugate, that's the same thing as W conjugate to the fifth. I think that's the conjugate for multiplication. That's okay, right? Okay, yeah. I think we're good because of that property there. My complex numbers are pretty weak, so I'm going to be struggling through this, but that's okay. Now, annoyingly, this is Z squared, but that's Z cubed, and that's W to the fourth, and that's W to the fifth. Like, we just don't quite have the same powers in either case. I for whatever reason, I feel like we should get rid of the z in this equation. I don't quite know why. But let's at least try that and see what happens. So we want z squared. So I'm going to raise these sides to the power of 2/3, I guess. Now this is a little disgusting. But if we just roll with it, does the squared gets rid of the negative sign, does it not? Uh, yeah, I think it does. Because it's like we're taking the 1/3 power and then squaring each side. You could think of it like that, or the reverse order. So w to the 10/3 times w conjugate to the 4 equals 1, allegedly. Um, now what? I was hoping we could find some sneaky way to... We have w times its conjugate, so I was hoping we could do something here. If we could say this, right? Um, but the only thing special about w times w conjugate is that fact, right? I don't know if that's going to be a particularly helpful fact. For this case. I wonder if a better strategy is to assume certain forms for z and w and try to find a contradiction. Because this kind of solving the system of equations thing seems a little rough. Um, I think I'd rather do that because I don't know where to go with this work that I'm doing here. Um, oh, w times w bar is real, and w divided by w bar is imaginary. Uh, Is the work I did here actually helpful, or how are you getting that? Usually imaginary. Okay. Oh, wait. I mean, maybe I need to keep this work going. Oh, Atharva, you're the one who asked this question. You do have a printed solution for the question, but you're unable to maybe understand it? If you want, feel free to post that and we can just kind of work through it. Um, maybe this is a novel, what I'm doing. You're thinking W to the 11 over W times W bar to the 11 over W bar. Huh. I think I'm going to look at the solution that Atharva is posting here and see if we can work through it. Because I can't quite figure out how to think about this one. So spoiler alert. Okay. Yeah, that does seem to be the answer. So we're starting up here, going down, and then we'll meet a little more off to the side. Got in just for the spoiler. Yeah, nice. Uh, oh, wait, so z cubed is minus w squared, or w to the fifth. They're saying z squared is 1 over w conjugate to the fourth. How do we get that? Oh, because it's just dividing that equation. I see, I see. Oh, hey again, Vivon. And so if this is true, then it's also true of their magnitudes. Okay. And they take that equation and square both sides to go to the next one. They cube that equation? I don't see where this is. Oh, to get the z's with the same power. Okay. Interesting. So they got the z's to have the same power, so they could set the other sides equal to each other, like these two sides. And that gives you that w, the magnitude of w to the 10th is equal to 1 over the magnitude of w to the 12th, which is the magnitude of w to the 22. If you multiply to either side is 1. And then that means the magnitude of w must be 1. And for some reason, and by like, say even like this equation here, if magnitude of w is 1, then 1 to the 5th is 1. And so the magnitude of z is also 1. Oops. Academy of Useless Ideas, thank you so much for the raid. Welcome in, everyone. For everyone's here on my end, please do check out Academy of Useless Ideas. Awesome stream. For everyone who's just coming in here, we're working on this complex variables problem at the top. I tried it for a little bit and got stuck, so we're just going through the solution and trying to explain it to the person who asked the question. I'm still trying to understand it for myself, though. Hey, refrigerator. The refrigerator. Thank you for the follow. Right now, we're working on this complex variables question. Before that, we were doing system of equations, and before that, we were doing choosing arrangements of like 9 squares, such that we cover all 3 rows and all 3 columns. We're doing some series. It's been a whole bunch of different things. We're doing this crazy rotating lines question. So there's been a little bit of everything. I'll keep this problem up for another like 30 seconds if anyone wants like a screenshot of it or something to look at for themselves, or just to try and read it quick, and then I'm going to scroll back down to the solution. So if you don't want a spoiler, then you're going to want to look away pretty soon here. All right, and scrolling back down. Okay, so I was just right here in the solution. I feel like I understand up to that step so far. Okay, and then these are just from the property I was using earlier, that a complex number times its conjugate is equal to the magnitude squared, and the magnitude is just 1. So far, we've shown that the magnitude of w and z are both 1. So, okay, they're kind of repeating, in this step, they're repeating kind of the same work as up here. They're just not taking the magnitude. That feels a little redundant. Like, why not start by doing this work and then take the magnitude and then reuse it later? But either way. Oh, so that's why I got stuck. I got to basically the same step, but I hadn't done the previous work up here. Like, this fact is really helpful because the w to the 10 times w conjugate to the... Oh, wait. Yes, okay, that's a conjugate, not a negative power. That's really easy to get mixed up. Like, that right there is conjugate, not a negative. Either way, so w to the 10 times w conjugate to the 10 is just 1. So you end up with w conjugate squared equals 1. And that's just a root of unity now. Right? So w conjugate is equal to 10r minus 1? What is r? W is equal to 1 minus 1? I have no clue what that bit means. I think I agree that w should be 1 or minus 1 if w squared is positive 1. Well, w conjugate, but in this case, there is no imaginary number that squares to positive 1, I don't think. Besides, like, well, does negative I? No, it doesn't. Then this question while practicing for JE exam. Question looks short, but looking at solution, I am amazed. It doesn't need words to know how much math skills it takes for such problems. Yeah. I tell myself this stuff and appreciate the beauty of complex numbers in mathematics. Nice. This one, it seems like there's a lot of shuffling variables around just for the sake of it. There are some pretty interesting identities that they're using, though. If w equals 1, then... Wait. Is this a vacuously true if-then? Like, we already know these two statements are true. They were given to us in the problem, right? Or I know it's not even like vacuously true, right? I think I'm using the wrong term. But either way, that seems like a weird statement to like. This statement just seems weird. What do they do after that though? Up here, we're repeating some facts from earlier, like from here in the problem. Oh wait, I'm sorry. No. Okay, wait. This line here goes with that line there. Okay, I did a bad job of taking my screenshots, but ignore that stuff up there because we already read it on this side. Z cubed plus 1 is 0, which implies z squared is 1 for some reason. My teacher asked me to prove a circle is a triangle. Help. Get a new teacher. That's the help I can give you. Wait, if z cubed equals -1, why does z squared equal 1? I feel like I'm asking you a stupid question. Because you square each side and cube root it, I guess? Okay. And z squared equals 1 implies that z equals -1. Why not also +1? Because this equation has to be true. Okay. Oh! Wait, I was thinking about this wrong. It's, z cubed plus 1 equals 0 comes from that equation. Z squared equals 1 comes from this equation, because we know that w is 1 or -1. But either way, it gets to the power of 4. So the -1 case isn't like a unique thing. These two equations imply together that z is -1. Okay. So why aren't we done? I thought we've just shown they're both purely real. And I guess there's two solutions. Maybe if w equals -1. Oh, they're... Oh, I guess there's 4 solutions. Or 3. No. There's a number of solutions that we don't care about. If w is -1, then z cubed minus 1 equals 0 and z squared equals 1. Okay. So there's, I guess, 2 solutions. W equals 1, z equals -1, and w equals -1, z equals 1. In both scenarios, they're both purely real numbers. Okay. Atharva, thank you for bearing with me. I think I understand this solution. What step maybe are you lost on? Sorry, I probably should have asked you that earlier. Please summarize. Okay. Let me just, yeah. Well, that's... I kind of want to rephrase their solution. So I want to start, there's so many steps. Yeah, there's some steps that are, they just are a little bit random as far as I can tell. I'm not very experienced with solving complex number problems. The one with taking the magnitudes is the bit that seems especially out of the blue to me. I want to substitute one of these equations into the other. I'm going to start, and I see we have a z cubed and a z squared. So let's try to make their powers match any way we can. With the left equation, I'll subtract over the w to the 5th. Sorry, that's w conjugate. No, never mind. This is good. And then I'm going to square each side to get z to the 6th is equal to w to the 10th. Over here, I'm going to cube each side to get that z cubed is w, sorry, not that. I know I keep apologizing. W conjugate, ugh, I'm not writing the right things. Z to the 6th times w conjugate to the 12th is 1. So now we can take this equation here, plug it in over there, because we know that z to the 6 is w to the 10th. W conjugate to the 12 equals 1. And so the part where I got stuck is I noticed that we could rewrite this equation as w to the 10th times w conjugate to the 10th times w conjugate squared. Like, I'm just taking this 12 and splitting up into 2 pieces. And I do that because when I see a complex number times its conjugate, I just kind of want to make a match. Because for any 2 complex numbers, if you multiply it by its, or for any complex number, if you multiply by its conjugate, that's equal to the magnitude squared. And so this piece here would be the magnitude of w to the 20th times w conjugate squared. But the thing is, we don't really know anything about the magnitude of w yet. So that's where I got stuck when I was trying it on my own. And we need to see if we can make some statement about the magnitude of W. And that's where they're doing this piece of the work here. And so what we kind of rewind to this line here. Sorry, I did a crap job of writing the boxes. Well, I guess like these two lines are the ones that we want. Let me just rewrite it. If z to the 6 equals w to the 10, then that implies the same must be true of their magnitudes. Hey, computer guy DR over on YouTube. I hope you've been doing well. Same thing with this equation over here. The same must be true of the magnitudes. Yeah, I have been. Thanks for asking. And the point of doing this is that, well, let me, I'm gonna do a really similar thing as the last time and take this equation and plug in w to the 10th for z to the 6th, because we know they're equal to each other. So w to this, this z to the 6 becomes w to the 10 times w conjugate to the 12 equals 1. Now, the great thing about this equation is that the magnitude of w is equal to the magnitude of w conjugate. So I can also write this. And now we can group them by the exponent. The magnitude of w to the 22 is 1. Merrick, can I do combinatorics like formal with set theory? Not really. I can only do really basic like counting problems, unfortunately. I'm sorry. And so now with this statement, we can raise each side's power of 1 over 22, I guess, and find that the magnitude of w is just 1. That's great, because now we can go back up to this equation, and it just got a whole lot simpler. Because this number here is just 1. 1 to the power of 20 is 1. Axel is asking, isn't the fact that conjugate w squared is positive enough to assume that w is real? I think we're about to find that, Axel, with that exact statement. I'm going to take this line here, and I'm going to continue it down below here. So now this equation that we got stuck on before, oops, just becomes, this is 1, so we get w conjugate squared equals 1. And so do we square root each side? Is that what they do here? Yeah. Okay, this is stuff I have no clue what this 10r minus 1 thing is, but I think you can safely just square root each side. So w conjugate is equal to plus or minus 1, but these are both purely real numbers, so we can also say that w is plus or minus 1. And it's probably the hardest part of the problem over with. Multiply the first equation by the conjugate of w to the fourth power. Use the second equation to simplify. You can get that z and w are scalar multiples of each other. Plugging in c times w into the second equation. Ooh, that's fancy, Luber. Yeah, I guess you end up in the same place as we got here, but that seems possible too. Okay. And so now what we do from here is we just consider both of our cases. So we have two cases, one where w is positive 1 and one where w is negative 1. And so let's see what it implies for our original two equations in each of these cases. So if w equals positive 1, z cubed plus w to the fifth is 0. And the other equation, z squared w conjugate to the fourth is 1. Okay, so the first equation would become z cubed plus 1 equals 0. The second equation would become z squared equals 1. So just kind of by eyeballing it here, if z cubed is negative 1 and z squared is positive 1, z just has to be negative 1. No other number really works there. So this is one solution to system equations, that w equals 1 and z is negative 1. Both are purely real numbers. The other case is w equals negative 1. So now our equation becomes z cubed minus 1 equals 0, and still z squared equals positive 1. So now z cubed is positive 1 and z squared is negative 1. By the same eyeballing it method, the only number that works here is positive 1. So the other solution we get is w equals negative 1 and z equals positive 1. In both these cases, we have two purely real numbers. And so that's why the answer must be, I guess, 1. For z and w are both purely real. Oops, no. I keep leaning back to stretch, but it's like my headphone cord is getting caught on a different cord. I just have too many cords on my desk because the cords are dragging on the thing that holds up my stylus, and then that falls down. I can just, I'll put it away from the cords. How about that? So, Atharva, let me know if that makes sense to you. If I was better with complex variables, I think that's how I would have approached it organically, or like, without knowing what the solution was already. No worries, Atharva. Thank you for the question. Your headphone cord gets caught on my keyboard and unplugs. Oh, yeah. Axel saying, what am I saying is that the square root of a positive real number can only be real. Yeah, I agree, Axel. We don't show that. Well, where do you get that earlier in my work, or earlier in the work? Oh, you're saying in this step, because this is a positive real number, right? Um, sure. I don't know. You're saying that that implies z squared is also positive real. Oh, yeah. Because this equation. Oh, Axel, that's sneaky. Oh, Atharva, yeah, I do this for free. You're never expected to pay anything, if that's what you're saying. Huh. Yeah, I wonder, because like the solution also went into the weeds like I did. I don't see an error in that logic though, Axel. So Axel is saying that even from this equation here, um, 1 over the magnitude of w to the 20th is a positive real number. So w conjugate and just w also have to be a purely real number. And from either of the two original equations, you then know that z must also be purely real. I don't see a flaw in that logic, and it saves a ton of work. Yeah, I can't think of a hole that I can poke in that. So maybe that's an alternate solution that is a lot easier. I just realized my humidifier hasn't been running this entire time. That's why my throat is starting to get sore. Ugh, I literally like haven't filled up with water and everything, just forgot to turn it on. All right. Well, neat question. Um, so right now it looks like the queue is empty. So I might go back to setting until we get another question. I barely even had time to think about. So this is from the real analysis class, and I barely even had time to think about this question before we got our first one coming in at the start of the stream. And so, oops. Down below here are the prompts that are referred to in prompt 2. A fourth term approximation, I guess, goes to n equals 3? And I guess, do we want to maximize the difference between the functions to figure out how good the approximation is? This is a lot of work if that's the goal, but let's at least like start on it. So if we're considering e to the x, then I guess R3x, I think it's third order. Or I forget how we were doing the... Let me just look at our notes. I forget if the what the number means exactly. If it's the number of terms or the it's the number of terms. So we want R4. My humidifier sounds like it's screaming in pain right now. I'm just gonna let it. I think it quiets down after a little while, though. I don't know. It's been making that noise recently. I don't know why. It's like a whistling sound. I assume maybe something got a little blocked. Doesn't seem like it's being picked up by mic though, so. And so in theory, we want to optimize this function on the interval 1/4, 3/4. So let's find the derivative. Oh, and of course, taking derivatives with Taylor series is really easy because it's just that first bit there. And so we would set this equal to 0 and find if there's any zeros inside this interval. I don't expect Zach expects, or I don't think Zach would expect us to solve that analytically. I don't imagine it's possible. So let's go to Desmos. Why does it look like a cubic function? It's not quite symmetric. There's probably a good reason why it looks like a cubic function. Okay, but on the interval 1/4 to 3/4, there's no zeros here. So we just take the maximum value at either the or whatever endpoint has a higher value, and that's at 3/4. Let's actually just use this as our calculator. 08575. Oh wait, it's an open interval? I'm still using 3/4. We can still use 3/4 as like a point of comparison because it's gonna be something incredibly close to there. I forget what the number was. 08575? Maybe there's no O. No, there is an O. 08. Oh, come on. I can't get it exactly on 0.75. I can get it on 0.751 or 749. Okay. 08575. Oh, dude, my memory is amazing. It's really not, but I don't think I correctly dealt with the possibility of W being purely imaginary in my logic. Particularly plug W equals plus minus KI. Yeah, that's what I was wondering too, if we could just consider each of the scenarios and look for contradictions. But guess I never went there. Cosine's even, so we do want one. Minus. Oh, I get it now. Zach is saying fourth term approximation to avoid confusion with orders. That is a weird thing. Yeah. Oh, that's funny. The remainders for cosine and sine are going to end up like looking a lot like each other. How's the physics going? It's not right now. Or I haven't done any physics since the last time I did it on stream. Um, the streams have just been too busy, which is a good problem to have. But if I want to actually keep on making progress on physics, at this point, I think I'd have to do it off stream. And normally when I'm off stream, I'm just too tired to think. So, not much progress, unfortunately. There's definitely no zeros between a quarter and 3/4. Oh, really? That's a part of stats that I actually kind of like. I thought that part of stats was fun. I hardly remember it now, but like I remember doing that also with like multivariable functions too. It's like, I don't know, stats a lot more enjoyable when you get to learn how to make the distributions rather than having to memorize a bunch of existing ones. And like it's kind of funny, like it's all heading away from stats students, but like when they're given, well, they're probably not given a Z table anymore these days, but well, some are. Usually use a calculator, so I feel like, but like this, you're just finding the area under the curve. Like the z tables are just a bunch of integrals that have been calculated. Like, and it's like sitting right there in front of you, but you would never know that until you took a calculus class. Even then, I bet students who've taken both don't realize that that comes from an integral. Um, I didn't do my job. I needed to find the maximum was going to occur at 3/4. 1.3633. That's the derivative, not the actual remainder. Ugh. I need to redo the first part. Unfortunately, calculators don't have the error function of x. That one I don't remember if I learned about that. I feel like I should have, but I don't remember it. Just the area under the Gaussian curve. Oh, okay. Well, I mean, then if that's true, then they can absolutely like it's called like normal CDF, but they can get the area underneath a normal curve. It's just not expressed like, as an integral, I guess. Yeah, Mary mentioned that he wanted to catch up to the class in time for Fourier's series. Um, and I don't think there's a ton of classes left, so I imagine we were going to have to get to them sooner rather than later. Oh, I know that Zach likes to keep things mysterious about what exactly is coming in the class, so we can like make adjustments. Is this what I have to face in the future if I want to become an engineer? Uh, you are absolutely going to have to face facts like e to the x is equal to this. You probably won't have to actually derive that formula, but they're definitely going to make you deal with it if you're an engineer. And it's incredibly helpful to have this, but I don't know. I think mathematically, it's pretty amazing that it's true. But yeah, if you're an engineer, as far as I know, you use series a bunch. Bluebird, that sounds familiar. Uh, I'm sure I've learned that at some point in a calculus class, but we haven't gotten to that at least in the analysis class. So we've kind of just been doing this so far, like taking the original function, subtracting off the series. Oh no, wait, Parth, I don't know what answer are you asking about. I'm still working on the one that's on the screen. Um, yeah, the Lagrange remainder. I remember just seen the formula before, but I think that's probably like the next thing we're going to talk about, probably even tonight. Yeah, Nevi, if you're 16, like you definitely don't not belong here. If I can phrase that confusingly. What I'm trying to say is that no matter what your like level of familiarity is, you're definitely welcome here. And it's kind of talk about the questions people are asking, and people often ask difficult questions that I at best half know how to solve. But if you have a question that isn't like remotely this complicated, it would be a welcome break, to be honest. So don't feel afraid to ask questions or like participate along. Uh, I guess I don't. This is the original function. I'm just gonna call it f of x so I can plug things into it. F of 0.75. Ooh, that's a very small number. Sounds good. Navai. 1, 2, 3, 4, 5, 6. 2 point. We're gonna call it 2.47. Times 10 to the minus 6. Let's go back and do the same thing for e to the x. I want to make that g. This is even easier. F of x is going to be the e to the x. 1 plus x over 2 factorial plus x squared. Right? We're going to bring you up to the top. F of 0.75. Ah! Ooh. 154 times 10 to the negative 2. So this is a much worse approximation than the one for cosine. The interval that we're given is kind of strange, to be honest. I wonder if there's a reason. This one, I'm not going to do as much of this by hand because I'm getting lazy. So for something that we'll find via Desmos, turn these off. H prime of x. Doesn't look like there's any zeros. It's very close to 0. I think we can relatively safely take 3/4 though as our highest point without. I mean, just as a little check, let's do h of 1/4 also. Yep, h of 3/4 is higher. 2.06 times 10 to the negative 7. So an even better approximation. I think it's benefiting by defining the thing with the number of terms because I think it's benefiting from having that x to the 7 term. Maybe. And maybe that's why it's good to go by order rather than number of terms. Because it doesn't feel like we're quite comparing apples to apples here. How about 1 over 1 plus x? I guess this is the one that makes you, that forces the interval to be like less than 1. We're not. I feel like using I as a function name is pretty cursed, so we'll go to J. J isn't like much better to be honest, but still no zeros. We can pretty safely think it's going to be J of 3/4 though, which is 0.18 181, I guess. Keep everything scientific notation. Collar cone. I am. Hope you are too. I'm just doing some studying for the analysis class right now. So I think I've just answered number 4. I wonder if there's some statement we can make about there probably shouldn't be a 0 in the derivatives. Like, all of these series are centered at x equals 0, and we're only looking on one side of that center. And we're not that far away from it either, so I think it kind of makes sense the remainder isn't like fluctuating up and down a bunch. It just kind of smoothly gets farther off in one direction. Yeah, actually, that makes a lot of sense to me because these are like polynomials. Like, with sine, we're using, I guess, a polynomial to the power of 7 to approximate it around 0. Like, I don't know exactly how it's like but it's a polynomial to the power of 7 is going to eventually look something like that. And so, of course, by the time you get out here, like, the fluctuation sign are going to hardly matter. Like, the remainder is just going to keep going up, up, and up. Okay. So that's number 4. Oh, hey. I assume this means prompt 4. That's actually, I was just happening to go in that same direction. Now I'm even more glad I did this in Desmos. Why is this here? Oh, it gives you a fraction, I see. I imagine we're still going to take the endpoint that's farthest away from where it's centered around, like the one that's farthest away from 0. It feels like there's certain symmetry in, well, maybe not. Like e to the x isn't symmetric as a function. Oh, yeah, you're right, Axel. We could do that. A half and 3/8. So 3/8 is slightly closer to the center. Oops. Minus a half, 0.002. 3/8, 0.008. So the minus a half is worse of an approximation because the remainder is higher. So 3/8 is closer to the center and it's a better approximation. How about for cosine? Ten to the minus 8. 10 to the minus 9. Same thing is true. Now with sine, 10 to the minus 9. 10 to the minus 10. So it seems like being, maybe the point of this question is that being closer to the center is desirable for getting a better approximation. I assume that's the thing to take home. Yeah. And that makes sense. Interesting that this is put before these three. There are onward problems from previous meetings, but I'm going to disobey Zach and go to the next one. Do we want to, well, do we want to do 7 or do we want to do 8 or 9? I mean, let's just do 7. It doesn't seem like it's going to be anything that revolutionary, but maybe. Let me get the formula in here too. Okay. Well, I mean, I guess I just did that. Well, okay, no, let's not do it like that though. Let's be uh a little better about it. We get so just cosine of pi over 4 is root 2 over 2. I think it's gonna be better to keep it as 1 over root 2 once we get into, well, I don't know. Hey, Lucia Milkovic? I'm sure I'm pronouncing that wrong. I remember coming on here when I was in high school. I've been inspired, and I'm now at uni, having two math classes, and wondering why have I done this to myself? Oh no. What math classes are you taking? That should teach you to be inspired to actually do math. Oh, so actually this is significantly different, isn't it? Because the odd terms won't drop out now, will they? I'm glad I went through and actually did this. That's, oh my god, what am I writing? What? Wait. Oh, dude, this is all. I'm spacing out. Oh my god. That's a little more like it. So we're gonna get this weird positive, negative, negative, positive, positive, negative. Like it's gonna be two positives, two negatives, two positives, two negatives. And I don't think it's possible to express that in one clean formula. I don't think at least. So we're at three, right? Zero, one, two, three. So third derivative. 1 over root 2 over 3 factorial. So we could plug in these four terms and just take a look at how close it is to cosine around pi over 4 as a way to check our work here. Linear algebra and the literal translation second one is mathematical analysis 1, but it's more like Calc 2 for Americans. Interesting. Okay. Yeah, and if it's being called analysis, that might be more like proofy than the typical like American calculus class. But yeah, no, I've heard that like in other countries they call math classes like pretty differently from how we do. Very much proof. Okay, yeah. So then we might even call it like real analysis then, which is actually what I'm studying for here. So be like a second semester of it, where we're getting into like the proofs behind infinite series. So good luck with it. For what it's worth, a lot of people like those two classes a lot. Um, they can be pretty painful though, depending on how they're taught. You have an exam on Monday, and I just now figured out how I should study for it. Okay. Good luck. Okay, then hey, that's not bad. It's like a pretty good approximation to me. It's a lot worse of a series though. All right, let's try number 8. What time is it? Okay. For today's stream, we're probably just gonna one second. I'm taking a screenshot and it freezes my screen. I don't know how it comes across on the stream, to be honest. But for the stream today, I'm probably gonna just ram my stream through until Zach's class starts in about like 20 minutes or so. At some point though, I'm gonna call the stream in about 20 minutes, but I'll keep the stream going until Zach actually starts his stream up, but it'll just be like the BRB screen or something. So just as a warning to folks. And on YouTube, it's just going to be cut off, but on Twitch, I'll raid over to Zach once he goes live. Ah! Oh no. I just duplicated the page. Okay, we're good. What's number 8? Do I already have it? I do have it copied. Oh. Let's not do a bunch of quotient rules. Let's be tricky. Let's say this is e to the x over x minus 1 over x. And let's go a step further and say that e to the x is, we know the power series for that. And that 1 over x is the same thing as 1 minus 1 plus x. Aha. So now what happens, this 1 over x can get multiplied into the summation. The summation only cares about n. So x to the n minus 1 over n factorial. Minus another summation, n equals 0 to infinity 1 plus x to the n. And these summations start from the same index, so let's make them into 1. Can we simplify this in any way? Boop, 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 boop. We could get a common denominator to get into one fraction. I'm not sure it's that helpful of a thing, but we sure could. Oh, really? Color cone? Oh! Yeah, that's a much better idea, isn't it? That'll give us a much cleaner answer. So I was just thinking, like, x to the n minus 1 is somewhere in that expansion, but actually finding that would be pretty painful. I like your idea much more. Just right from this step, go to the series expansion. And the cool thing here is that the first term of this series is just 1. So we can take that 1, subtract out that 1, and we just start the series 1 term later. And then same thing with dividing dx. Okay, that's much simpler. I was being needlessly fancy there. I am, Mary. Well, ironically, I didn't do the actual homework that Zach said to do. I was just going through the later prompts. And there's only like 1 left on the sheet. Well, I mean, I think it was like jokingly, but like you remember in class he was like circling things with the HW. It's not actual, like, you don't have to like do it, but he was saying like if you wanted to do some more work. Yeah, if you want to like talk about something in review before class starts, like let me know. Ooh. This is much more challenging, isn't it? This one you might have to go to the derivatives for. So you don't really have the same, like if you have x over that same summation, I don't see how you simplify that. Sounds good. Yeah, this one seems annoying. Axel in the YouTube chat saying it's 1 over the same summation. It's not x over. Uh, I mean, I was taking like this step here and flipping it, I guess. But you're right. I could have flipped that too and done 1 over that. No worries. In either case, I don't see what you do after that. Gotta go teach a category theory class. Ooh, good luck. You have a good night too. Yeah, I guess let's go to the old reliable here. Hopefully we can find a pattern. Let's take a few derivatives first. This quotient rule isn't the worst thing in the world, to be fair. There's much worse quotient rules on this earth. Low d high minus Wait, I did that backwards. No, I did that forwards. Low D high. Wait. Low, yes. Minus high D low. There we go. Do you remember on notebook paper? Yeah. It helps me write, like, you can make it be a blank page too, but I just know that my writing is gonna eventually, like, drift off like that. This has it does have graph paper too. That might not be a bad call, but I don't know. I do like the binder paper vibe. And also, I really like that. I mean, I think you mentioned you just got a tablet, but like the thing that you do with like just like writing on a piece of paper with a marker does show up like very nicely on stream. It's cool paper faux show. Actually, how does the graph paper? I don't think I ever even tried the graph paper. How does that look? Where'd it go? I didn't actually add it yet. That's not bad. That could be worse. I don't know. It feels a little bland because it's so like monotone. Yeah. I think that the binder paper is more of a vibe. Graphs, yeah. College I was too broke to buy notebook paper, so I took white paper from the printers and used that. Oh wow, that's a funny life hack. Just steal some of the printer paper out of the printers in like the libraries or something. Hey Tyler, 7 is the answer. Hell yeah. Hope you're doing well. Oh, this place has been looping for a while, I think. Oh no, it only just started to loop. It's 3 hours, 18 minutes long. I'm shooting for 3 hours and 30 minutes. Okay. I'm not going to bother changing it because I'm lazy. And it's a good song. Yeah, graphs will be okay with it. It is graph paper. It's fair. And also, I lied. This quotient rule is the worst thing in the world, I think. And we're centering it around 0. Ugh. There's got to be a simpler way to take the reciprocal of a Taylor series, right? I feel like someone somewhere has figured out a formula for that. Yeah, and I feel like, I mean, I would say at my school, it'd be pretty easy to do that and not get spotted because the printers are everywhere, like you said. You can always find one that's off in a corner. But I think it's just like a normal librarian who spots you, unless they're just really having a bad day or they're, I don't know, like something happened to them, they're probably just gonna like assume you're broke and let you slide and pretend they didn't see anything. Find the derivative of the reciprocal. Well, yeah, I guess that's what I was trying to do, Territar, but this is quickly getting painful. I don't want to take like 2 or 3 derivatives ideally, but that's just getting. I don't really want to take another derivative, much less 2 more. I was hoping for some kind of like sneakier way. Yeah, honestly, all throughout college, I just reused it. I reused my notebooks from high school, and like I still have them too. But like, it's such a waste. Where or in any class, they tell you to buy a journal for it, but the last like at least half of it always went unused for me at least. And so I started to just like make a big fold in a page so it's easy to find, and then whatever's after that is for another class. Um, and I could fit in like 3 classes in a notebook easily. Leibniz's rule for the nth derivative. I don't. Have I heard of that? Oh, that's like I think I've heard this is another word for Feynman integration, but that's not what you're talking about, Teratar. I don't think. This looks more like it. What the heck? Wait, this is a thing? It's a generalization of the product rule, and it's just like a binomial expansion? That's kind of hilarious. I think I've seen this before. Um, that does seem possible then, yeah. I think I'd rather just look up reciprocal of Taylor series and see if there's anything interesting. Times at 510? Okay. Oh, don't use sine to the -1 for the reciprocal of sine. Wait, what's this? Oh, factoring x out? Oh. That's both sneaky and beaky. It's two things at the same time. Oh my god. That's the type of trick that I was hoping for. Uh so we do take the reciprocal of the thing that I just found. I believe there's conspiracy in big books to use science the -1 to save on ink. They save 10 cents per book. You know, probably, Barry. Yeah. It's the worst notation. Whenever expert over Taylor series 2. I mean, you could just multiply it in though to into the parentheses, I think. All right, so that's where my mind was going. Uh where does this starts at 1. When n equals 2, it's x over 2, x cubed over 3 factorial. 1 minus negative x over 2 minus x3 over 3 factorial minus dot dot dot, right? And so here we don't even have that 1 over x thing to deal with either. We do get a smaller, well, we do get a radius of convergence here, but wait, so is this the double summation? Wait, this would be a double sum if it's what I'm, no. Yes? Ooh. I'm thinking about this wrong, aren't I? I gotta wrap it up soon here. I thought this thing on the right matches the formula for a geometric series because it's 1 minus something. But the issue is that something is infinitely long. It should be x squared, you're right. Well, wait, okay. Maybe we need another... No, we don't know what that sums to. I was hoping we could say that that sums to just a number and we could put that number in there, but we actually we can't. I don't know, we don't know what that sums to, do we? Okay. That's a really neat thing. I don't quite know how you do it. I feel like you can do it. I just don't know how. Yeah, it got messy quick. That's why I wanted to look for a trick. I do love this idea, but going from this to this is actually not so clear to me. I may need to wrap things up for the day here, though. So, um, yeah, I do just kind of need to go here. So what's gonna happen? I'm gonna cut the YouTube stream off here, and then on Twitch, I'm gonna have a BRB screen up. And as once that goes live, I'm gonna raid into him. So the stream is basically gonna be over. If you want to go watch Zach streams after, then hang out, and I'll send you over. Yeah, I actually do have some snack food this week. I remember to actually buy something from the grocery store that wasn't like loaded with chemicals and weird stuff. But yeah, so I'm gonna like I don't want to like broadcast our conversation in Discord before the class happens because that's just like not cool. So it'll be our B screen. And I'll just keep the music playing. But yeah, so Computer Guy and Territar over on YouTube, thank you both so much for being here, and we'll see us here on YouTube also. Thank you. I'll be back on YouTube on Saturday. 7 concurrent viewers on YouTube? What the hell? Thank you. I don't know what stage of the stream that was, but... oh, I'll have to look into that, Territar. That'll have to be another time, I'm sorry. Goodbye, YouTube.